private image registry. So, I mean, the obvious one, I think the sort of first thing people think about with security is a malicious actor. So either someone from the outside or a rogue employee who's putting a backdoor into your production server image or something like that. But I think there are actually some other concerns that might be at least as important. One is just inadvertent changes. So a developer pushes some bug fix that they're working on that maybe is not quite done to the production image accidentally. Or the team for production application A accidentally pushes on top of the image for production team B. So if you have authorization rules in place, you can prevent these kinds of things from occurring. Another thing that it can give you is the ability to enforce naming standards. So you can perhaps avoid typos like database, or also prevent people from polluting your image namespace. So maybe you don't want my quick hack being a top-level image in your repository. So what do I mean sort of generally by security with an image registry? So 3 things: authentication, authorization, and audit logging. So first one of those, authentication. And this is answering who is the user. So when someone comes to talk to your image registry, who are they? Before we get into how you do that, a quick discussion of why. And basically it's because authentication enables the other two. So it's really hard to do authorization without authentication. You don't know who the user is, you can't decide what they're allowed to do. And also makes your audit logs more useful. So an audit log that says, an image with this hash was pushed at this date is sort of useful. An audit log that says, Jane Doe pushed it, and that's a little more useful because now you can go ask Jane, what series of events led to that image getting updated. So authentication. There are lots of choices for authentication, ranging from the simple basic username and password, SSL. I work in an environment where we use Kerberos for authentication. And then also many organizations, for various reasons, some historical, some organizational, have unusual or complex authentication systems. So web-based systems where at least a couple places I've worked, when you went to visit any web app, you got redirected to some central web authentication system in the company, which then generated a cookie that redirected you back. Whatever it is, my general point here is that a lot of people have sort of unusual authentication choices that are never going to be supported by the tools directly, and so how can we incorporate these unusual systems into securing your image registry? So along with this, there are also lots of choices of image registries themselves. So if you've looked at running your own image registry, you've probably at least looked at the first one here, the open source Docker registry, simply because this thing, it's open source, it's available as a Docker image on Docker Hub, so simply Docker run registry :2, and now you've got a basic image registry running, and there's probably at least 10 of these running in my company currently. People just fired one up to get it, something going. But there are also some commercial choices that might be interesting if your needs are kind of happen to fit into what they support. So Docker themselves has a commercial version of the registry called Docker Trusted Registry, and CoreOS has Key Enterprise. Both of these are targeted at a kind of very traditional enterprise type of environment. They support LDAP. I think they both support Active Directory. Neither one supports Kerberos, which is sort of relevant in my case, and neither one really supports a customized authentication system. So if you want what they support, you're great. Otherwise, you're kind of out of luck. Another one that's somewhat popular and kind of notable is Artifactory from JFrog. It's interesting because they explicitly support putting a reverse proxy web server, so either Apache or Nginx, in front of the registry. And you can do any sort of authentication that you can do in Apache or Nginx, and then they'll just trust the remote user header that the reverse proxy sets. I actually got this working with Kerberos. Admittedly, it took a while. Why it's kind of challenging is because you've got all of the registry traffic going through this web server, and in order for this to work, it'll probably make more sense as I show some of the diagrams. You have to authenticate some URLs with whatever your authentication, your sort of in-house authentication system is, Kerberos or whatever, but then you have to let others pass through unauthenticated because you've already authenticated them elsewhere. I realize that's sort of confusing and probably will make a little more sense in a bit, but nevertheless, you can get this to work. We ended up not using Artifactory for other reasons, but it's definitely something to consider if your main concern is just a authentication scheme that's not supported by the others, but is something that you can do in Apache or Nginx. So let's say none of those commercial choices work for you. Well, the nice thing about the open source Docker registry is that it's got a lot of hooks to it. So in my case, I've actually set this up without modifying the registry itself. So I'm using the stock image from the Docker Hub. It is open source, of course, so you could certainly get into modifying it. But the trick on the authentication piece is that, of course, you're dealing with the interaction between the Docker daemon and the registry. And so if you really want to truly customize that, you'd have to modify the Docker daemon as well. And we certainly didn't want to get into building and distributing our own customized Docker daemon. But we were able to use the hooks that are built into the registry and the client, and I'll explain that as we go along, in order to do what we needed without modifying them. So this image is from Docker's documentation, this link down here at the bottom, and it shows the authentication and authorization flow. I didn't quite explain this. So the registry, one of the things it supports is a external authentication and authorization service. So they refer to this as a token service because what that service issues to you is a JWT token, this token. So let's say you wanted to use this external service. The flow goes like this. So you're on your machine and you've got the Docker client. You say Docker poll, for example, and some image. The Docker client talks to the Docker daemon. Typically this is local through var run docker.sock. So the Docker socket is typically how the Docker client talks to the Docker daemon. And then you can kind of follow the numbers here. The Docker daemon is going to send a pull request to the registry. In this case, where you've configured the registry to have an external token service, step 2 there, the registry is going to send back a redirect. It's going to tell the Docker daemon that it needs to go talk to this external service. It's basically just a standard like HTTP redirect. The Docker daemon is then going to go to the authorization service and basically take the URL that the registry gave it, which includes information about what it is you want to do, and I'll show an example of this later. It sends that to the authorization service. The authorization service, you can authenticate to that service. All that's supported by the Docker daemon is passwords and OAuth 2 tokens. But we'll talk a little bit about how you might get around that in just a little bit. But so you authenticate, let's call it with HTTP basic authentication to the auth service. The auth service then looks at the operation you've asked to perform. So in this case, maybe this pull of this given image. And it's entirely up to you, of course, because this is a service you're running, decides whether or not that action is allowed. Either way, it generates a token and returns it. That's step 4. So you get back this token. The Docker daemon gets back this token. It then sends it, step 5, back to the registry. The registry looks and says, did the authorization service allow what you want? If so, then success. Step 6, you get, in this case, your image that you're pulling back. A couple things of note here. One that I think is particularly interesting is that the registry and the auth service don't talk to each other. Notice that there's no communication between the two. The only way they communicate is through this redirect and the token. And the way that works is that they share a public-private key pair in the form of an SSL cert. So the authorization service signs the tokens that it generates with a private key, and the registry, when you configure it with an SSL cert that's the other half of that key pair. It's able to verify that the tokens that it's being handed came from an approved auth service.
Are you open to questions?
Yeah, sure.
First, I assume that disclaimer at the bottom is not correct, right? Proprietary and confidential.
Oh, sorry. I tried to rip that off of all. For some reason, this is my company's external template, and it still says that. And I tried to take it out, but I missed a slide. So yes, that is not. Ignore that, please.
More seriously, are you talking about being able to do this Docker pull without a Docker login initially, and then is that authentication flow web-based?
So I'll talk. Let's save the Docker login part for later because I'm going to talk about that. The protocols here are, I believe they are all HTTP. But as far as particularly the authentication piece, you're limited in this case by essentially what the Docker daemon supports, because you sort of control the Docker client. Actually, I'll skip ahead to the next slide and show this, but you don't really control the Docker daemon, and so you're kind of stuck with what it supports, which is basically password auth or OAuth 2, but most people don't use OAuth internally. So kind of alluded to this, but so the daemon supports password authentication. In my case, I want Kerberos. Well, so I control the auth service, and through some mechanisms I'll talk in a little bit, I control the client. And so I can inject a couple of extra steps. I call them 2.8 and 2.9 here, where I can reach out to the auth service using whatever protocol I want. In my case, I did it with HTTP, but HTTP with Kerberos authentication. I reach out and get a password, and then Docker login or something like that in order to give the Docker daemon a password that it can hand back to the auth service. So this is definitely the part of this that seems a little bit kludgy. It works beautifully in practice, but is definitely kind of abusing a few features to get what we want. Maybe someone will come up with some more elegant way of doing this, but this definitely does work, and we're using it. So let's see. Right. So that auth service, we're sort of generally calling auth service because it really does both authentication and authorization. There are actually some choices here of ones that exist. There's a very simple one that actually is in the Docker registry GitHub tree. That's the first one up there. It's written in Go. It's basically just an outline of how you would write one of these things. But it's a place you could start if you wanted to kind of customize one. The second one there is also written in Go, but it's more full-featured. So particularly if you're kind of comfortable with Go, that's probably a good place to start. It supports a few additional authorization schemes. I think it supports a few like external ones, like a GitHub and a few things like that. But I think it mostly is sort of username and like password and LDAP. But the nice thing about these is they're all fairly simple programs, and so you can modify them. The middle one there from OpenDNS is a Python Flask app. Again, it's very simple. The code fits on a few screens. So if you're comfortable with Python, that's potentially a good place to start. Portis is kind of interesting because it's a much bigger thing. It's a Ruby on Rails app. It's got a big, pretty UI. Portis is a little bit different, I think, from the first three. It's really intended to be the UI for your Docker registry. So it does give you a nice graphical UI for the registry, which the open source registry doesn't have a UI to it. All it will feed you is JSON. So that's can be a little hard for users if they want to navigate the registry and see what images you have and that kind of thing. So Portis is interesting in that regard. On the flip side, if you want to modify it to do your own sort of custom authentication, that's rather a bit harder unless you're pretty comfortable with working with Ruby on Rails. In fact, I am comfortable with working on Ruby on Rails, and I still really couldn't do it. So I think Portis, I think, fits better into the I need a UI to view my registry. And then the last one that's up there is also kind of an interesting one in that GitLab is an open source and commercial clone of GitHub that you can run on premise. And fairly recently, they added support for basically using the accounts that you have already set up in GitLab as the auth service for the Docker registry. And basically, if you check the box, they'll basically just fire up a copy of the open source Docker registry in a container and rig it up so that it's pointed at GitLab for authentication and authorization. So if you've already kind of invested in GitLab as a home for your accounts, that's a potentially interesting choice. So given all that, I'm more comfortable in Python than in Go, so I chose the middle one, and so we are going to look at that. Hopefully this kind of works. So by the way, this is where I stole that image from. By the way, this is Docker's documentation page for using a token service. So it's not, I would say, not the easiest documentation to kind of wrap your head around the first few times, but it's sort of the place to go if you're interested in setting this up. So this is the project I mentioned. It's a Python Flask app. There's basically just a handful of Python files. I think I'm going to shift over here and show you the code. So this is basically a Git clone of that app. So there are 3 Python files. I'll kind of show them all pretty quickly. So the top level one is this app.py. So if you look at the bottom, sort of your standard Flask app. And really this basically just has one endpoint to start with, which is this /tokens. So the way you set this up, which I'll show in a sec, is that when you start the Docker registry, you give it a URL to talk to for a token service. And so in this case, you would run this Flask app somewhere and then give the registry this, let's call it auth.example.com/tokens as the URL for the service. This decodes the parameters that it gets from the registry. In this case, it does require basic auth, so this is where the Docker daemon has to authenticate to it, so it requires username password authentication. And then it has a function that it calls to see if you're allowed to perform the action. So in this case, at the moment, the way they have this written, it allows anything. And switch over to the auth file. This basically is just a file that implements HTTP basic authentication for Flask. In the checkoff method does exactly nothing other than returning true. So obviously we'll have to modify these a little bit for setting up something where we actually want restrictions. And then the last file is this tokens file, and this basically implements the logic to generate a token in the format that the Docker registry is expecting it. So this code I think you mostly don't need to look at, but it's basically just some code to produce these tokens. So let's start with just running the basic service kind of with as little modification as possible. One thing, since I'm giving a talk that involves security, I thought it would be probably bad form if I ran things as root, but all of these things run as root by default because, yeah. So the one modification we're going to make kind of right from the start is to add this user add call in the Docker file for this Flask app. And the reason you need this is that the Python web server that I'm using, I know it's got some crazy name. If you run it as some UID, if you say Docker run in a UID, it tries to look up that user account for some reason. I don't know why. So we can't just give it a random UID. We have to create an account. So I'm going to switch over to terminal here. Oops. So this is a directory where I've basically cloned the OpenDNS project. made the modification to the Docker file and a few other minor things that don't matter too much at this point. So we're going to make a Docker image of this app. In order to avoid problems with Wi-Fi, I have ensured that all of these things are cached locally, so that hopefully my demo is entirely local and not dependent on the rest of the world. So we've got an image. Let's see, make sure I'm not forgetting anything. Great. No. Okay. So now we want to run that. Obviously, in production, you use something fancier like Docker Compose or Kubernetes or some such thing. But for demo purposes, I wanted to keep this as simple as possible. So I just have a very simple shell script to run the container. So with Docker run this. Things that are interesting to point out, I mentioned earlier that the registry and the auth service need to share a key. So we're bind bounded in an SSL directory. And the key that is kind of shared with the registry is this auth key. But then separately, this service is running as an HTTP server. Again, we care about security, so we're going to run it as HTTPS. So it needs a key and certificate to be an HTTPS server as well. These can actually be, you could use the same key for both of these. There's really no sort of security concern with that. But just for kind of fun, I made them separate keys. And then I think a lot of these other things are just necessary environment variables to get the token generating code to do the right thing. But then I am specifying this user ID that I created so that it doesn't run as root. So we're gonna remove the container I already have running and then run that one. All right, so it's running. You can ignore the Docker client container for a sec. I'll show that in a bit. But basically, we have the auth container running. And let's start watching its logs. So it's listening on port 8080. So this is all, by the way, I have a Mac. I'm using Docker for Mac. So it's a Mac running a Linux VM. Docker is running inside that VM. So I'm going to use the host name of localhost basically in all these, but I actually have I generated an SSL certificate for localhost so that all the SSL bits work as expected. So let's see, now the registry. So let me switch back to the text editor because it's a little bigger and easier to see these things. Right, so when you set up the Docker registry, you can basically give it no configuration and it will do some reasonably intelligent things. You can configure it on the command line via environment variables, which works for kind of most things, but when you get into some of the more complex configuration bits, there is not actually a way to represent them as environment variables, or at least I think you have to basically serialize YAML in the environment variable value. That's not the greatest thing in the world. So if you kind of are setting up like a production registry, the recommendation is that you create a YAML config file for it. The kind of downside of this is that if you do that, it overwrites the default one. And so you have to actually supply all the default values as well. So that URL up there is their documentation. Basically, this is the default config file. So this is the standard one from Docker, and this basically they say you should start with this. So we're going to start with that, but then we are going to modify it a bit. So I didn't come up with a super great way to show this, but I will just highlight the portions that we have changed. So first one is to tell it that we have this token service. So the realm in this case is the URL for the token service. The service string, as far as I can tell, doesn't matter for anything, so I just put registry. Basically, it's like, what is this thing, which is the registry, but I don't think it gets used for anything. Issuer, on the other hand, does matter, so that's a string that says what is the auth service going to issue tokens as. It's an arbitrary string, they just have to agree. So when you set up the auth service, you have to tell it what string to use as the issuer in the tokens, and in the registry, you have to tell it what string to expect the tokens to have in them. It's just a little bit of a, I guess, belts and suspenders to make sure you've got the right things talking to each other. So we're going to use the string auth in this case. And then this is the public side of the key that is used by the auth service to sign tokens. So we've added that, and then I think the other thing I added was basically an SSL cert so that the registry itself is running with HTTPS. So we will fire up the registry. So now we have a registry and an auth service. Let's start watching the registry's logs. So it has started up. And then lastly, because again I'm running on a Mac with Linux and VM, whatever, I have a container here that I'm going to use as to run my Docker client. The only reason for this is just to get on the right network that's with the other containers. In kind of a regular environment, this would just be whatever machine you're running Docker on. But it's rigged up, so it's sharing the Docker socket, so same Docker commands working here as outside. So we need, now we have a registry to talk to. So I've got the Alpine Linux image here. And so the way, if you haven't dealt with I mean, some of you, probably most of you have seen this at this point, but the way you basically tell Docker that an image should go to a private registry instead of the Docker Hub is by giving it a name that includes a slash, basically, so that it turns into something that looks roughly like a URL. It's the weirdest heuristic in the world, but that's the way Docker does it. If your image looks like that, then it goes, oh, that must belong to a registry, and so when you say push and pull, it will extract out the hostname and port and push to that instead of to the public Docker Hub. So we're going to take the Alpine image that I got from the Docker Hub that's just called Alpine and tag it with a name that includes our registry. So now we can try to push this. Oh, but we haven't actually authenticated to the auth service. So I didn't quite talk about this very much, but one of the things I did change in here, so you may remember in the unmodified code, the checkoff method just returns true. So a modification I didn't mention yet is that I've modified this to actually do some, in this case, not very good checking. The passwords are just hard coded here, but so some checking. And so our Docker daemon tried to talk to the auth service. Authentication failed, and so we got rejected. So let's see. Oh, right. So this then gets to talking about Docker login, which you had asked about. So let's go back here. So how do we authenticate? So I mentioned that we're going to kind of add these extra steps where we go and ask the auth service for a password of some sort and then give that to the Docker daemon. As far as giving it to the Docker daemon, the simplest thing is that you can just run Docker login. So you could somehow get a password, run Docker login, type in a username and that password, and then everything would work. But that's not very much fun, particularly if you're kind of doing this on a regular basis. Like you'd like that to be a little more transparent for yourself or your users. So if you go look at the Docker documentation for Docker login, there's kind of an interesting thing hiding on this page. So you start at the top and talks about Docker login, but then there's this bit about credential stores. And these are intended for storing passwords in your like macOS keychain or GNOME keychain, that kind of thing. But the way it works is it's an arbitrary executable that the Docker client runs when it needs a password. And I love arbitrary executables that I can control. So we can do something interesting in this, like for example, go and get a password from somewhere. So in this is the way I chose to add the step where I go and use Kerberos to talk to my auth service, authenticate with Kerberos, get back a password, and then return that from the credential executable that I've written. And the Docker client picks that up, sends it to the Docker daemon, and magic happens. So how do you actually go about using one of these things? Let's see if this recovers on its own. It seemed to earlier. Right. I hit X to show it. So how do you do this? So in your Docker config file, so your Docker is configured by a config.json file that lives in $home/.docker. And in there, if you want to use a credential store, you put some simple JSON, so you basically say cred store and some string. And what Docker does is when it needs a credential, when the Docker daemon says, hey, I need a password for this thing, the Docker client runs docker-credential-that string. And that has to be in your path. So I've looked at the code in Docker. That's all the control you get, is the Docker just executes docker-credential- the thing you said. So you need to write one of these that has to have that name, and it has to be in your path. So we are going to show that. So over here, so first let me show you what this, let me kind of walk you through how this works. So I'm going to grab the curl command out of here real quick. So, oh, right, I should explain. I should show another thing. So, back in our Flask app, I've added an extra endpoint. So you may remember this tokens one was all that was there in the first place. I added one called get password. And as I said in the comment there, you can do whatever you want here because you are controlling both ends of this. Just for the simplicity of this demo, I've stuck with HTTP basic authentication. But literally in our environment, we have a similar Flask decorator that does Kerberos, and so ours just has Kerberos there. And basically you hit this, and I've been using this air quotes password a lot. Of course, this could be any arbitrary string that you can validate later. What I chose to do was basically just reuse the tokens that you are already able to generate out of this app. They're signed, so you can validate later that you are the one who issued it. And JWT tokens have an expiration built into them. So they have a not valid before, not valid after timestamps that are in them, which in our environment is great. We use Kerberos, and one of the things we like about Kerberos is that tickets expire. So you can make these JWT tokens expire as well. At least what I did is I have them expire after an hour. So our Docker cred store thing is a little fancier. It checks the expiration and goes and fetches a new one if it needs to. I didn't do that for the demo, but it seemed like just reusing these tokens was a good way of generating a password that you could use. It is a pretty good sized string, but it seems like nothing in the path has any problems with a string that's maybe 512 bytes long or something. But in this case, we're going to do basic auth. I'll show just a little bit about that in a sec. The basic auth thing sets request.user, so we take the user basically that authenticated with basic auth. We generate a token where the subject, this is just a field in the token, the subject, which is what's the subject of the token. We stick that username into the token, we log it, and then basically we send it back to the user. The username in this case doesn't matter because we are embedding the actual username in the token, so we just use this kind of fake hard-coded string as the username. And back here in the authentication function, for this step of the process where the user is actually authenticating to us, we're going to expect that they authenticate with the username password demo user demo pass, and if so, we'll consider that valid. And then separately for the tokens method, which also is doing basic auth, we're going to expect that basically we get back a token that's valid. So if the token, when you call decode token, if it's invalid, like it wasn't signed by you, it's just not a valid token, etc., it throws an exception. So you can just catch that, and if that happens, you know you didn't get a token. But if decode token succeeds, then you know you have a valid token that you issued. You can pull the username out of it again. So we stuck in the username in is the subject. The way you get that out is this sub field in the token. So we can pull that back out, and now we've round tripped and know that you know who the user is. So I want to show the client side of that. So to start with, I'm just going to run curl. So you may have noticed down here that that's the server side of this. So curl connected, the server authenticated them, issued a token. We got a token back over here. So the token is, or password in this case, is this fairly long string. I'm going to run out of time here, so I'm going to try and speed it up. One thing I wanted to say really quick that's interesting is that these JWT tokens consist of 3 pieces separated by a period. So you can kind of see them. There's the first piece, and then the second one ends somewhere in here that I'm not quite seeing. But anyway, let's grab the first one. And so you can, the first 2 pieces are just base64 encoded JSON. So you can look at them pretty easily, which is useful when you're debugging this. And I happen to know you need to add a little padding to this one. So that, this is, you know, not super interesting. It basically just says what kind of token it is. I wrote a little Python script just to make this easier to see. So there's the 3 parts of this token. So the first part basically tells you what kind of token it is. It's a JWT token with a few properties. The middle part is basically all the data. So the subject, here we see the subject that we put into it, a demo user. The access bits and stuff don't matter in this case. We're just using this really to convey the subject. So the rest of this, the expiration, invalid after and not before, is what the X, IAT, and MBF fields are. So that's the expiration timestamps. And then the last bit, I haven't bothered to check, but I'm going to assume that's the signature. So those are the 3 parts of the token. So now let's actually configure Docker to use this thing. So we have a config.json. It's very simple. It says cred store, so we're going to copy that to utility.docker. And then we have, then we have the script. So Docker has a really simple API for talking to these things. Basically gives it a first argument of what you want it to do. The one we care about is get. So we're just going to run it manually. To see this, you call get. So this thing now did curl, got a username and password, and outputs it in the JSON format that Docker expects. So now if we go back and of course my demo fails at this point. Oh, right, I didn't put that in my path. Yes. All right. So yeah, security is like unit tests. You never trust it unless you've seen it fail. So you've seen it fail. All right, let me see if I can talk a little bit about some of these other parts before we run completely out of time. So authorization, what is the user allowed to do? So you remember this diagram. So, and I mentioned this before, when the registry redirects the daemon to the auth service, this is the header, what the header looks like. This I just stole out of Docker's documentation again. So it tells the daemon where to go. Service field, that's the one I mentioned earlier. It's there. I guess now that I think about it, what it's there for is your auth service could do something based on that if you wanted. So that's where the service field comes in. But then the thing that's most interesting is the scope. So this is basically what the user is trying to do. So in this case, they're trying to work with a repository. The only other thing that I've ever seen there is catalog. You can ask the Docker registry API for a catalog or a list of all of the images on the registry. So the other thing you can get there is basically a request for the catalog. But mostly you're probably going to care about someone who wants to work with the repository, the name of the repository, and the operations they wish to perform. In this case, for whatever reason, pull always implies push. So every time someone tries to pull, it also asks for permission to push, or the other way around. If you push, it asks for permission to pull. The three actions that exist are push, pull, and star. Literally an asterisk. That's what you get. I don't know why. It's crazy. And that's delete, basically. That's what that means is delete. So if the user tries to delete an image, which is supported by the API, the registry by default doesn't allow deletes, but you can turn them on. And if you do that, then what you get is a star. So I'm kind of out of time, so I'm not going to actually demo this, unfortunately. But back over here, so this code has this get allowed actions, which is parsed into an array. And here you could do whatever. You could remove actions that are allowed or that kind of thing. Let's see. And then, so I'm just going to run through this real quick and skip the demo again. Audit logging, you care about audit logging. So there's a couple ways you can do this. One is that the registry, if you notice down here, has been spitting out essentially web server logs. You could get some amount of historical information from that, but if you really want the full details, in particular who did something, then what you have to do is the registry supports a separate thing they call notifications. And basically, you give it a different URL. It can be on the same server or a different server. And if you configure that, then every time something happens, push, pull, whatever, the registry sends a JSON blob, big long JSON blob with all kinds of details of what happened to that service. And you can pull out the interesting bits and save them. I'm going to show this very, very quickly. So down here I have it commented out, but basically I added a thing. It takes the blob, extracts stuff you might care about. In our case, we save it in the database. And I think I'm time-wise going to skip.
Up to you. I mean, we're just a little over, so I
Okay, let me talk about this just really quickly because it seemed like Kubernetes was a popular topic. So this is all great if you're just dealing with pure Docker, but in our environment, and it sounds like a lot of other people's environment, there's interest in orchestration frameworks. They also need to pull images, so if you tell Kubernetes you want to run something, it's got to go get the image as well. In the case of Kubernetes, the agent that runs on each machine where Kubernetes is going to run containers or pods is called kubelet. Kubelet in this context is the thing that is pulling images. It acts like the Docker client. So previously we had on kind of the machine where the user is, we had the Docker daemon and the Docker client. In a Kubernetes world, you still have the Docker daemon, but you have kubelet instead of the Docker client. So kubelet is acting as the Docker client in this case. They do that by literally just pulling in the Docker code from GitHub. So because of that, it's not a rewrite. It's the exact same code, just running in kubelet instead of Docker client. So you have all the exact same choices. So you can run Docker login manually if you never change passwords in your environment. You can just go to each of your Kubernetes slaves and run Docker login. But if you're doing that, you're probably not at this talk. You can use a credential manager, just like I showed, because it's just going to use it just like the Docker client would. The thing that's kind of unique about Kubernetes is that the other thing you can have people do is to specify their own password, which token in our case, as what's called an image pull secret in their pod manifest. So they actually upload the token itself as a Kubernetes secret, and then they reference that in the pod manifest as my image pull secret is stored in Kubernetes secret with this name. When you do that, Kubernetes or kubelet creates a one-off config.json and sticks the password in there. Because when you run Docker login, all it does is stick your password in config.json in plain text. So that's what kubelet does if you give it an image pull secret. It makes a config.json, sticks the password in there, and then does the pull and then throws that config.json away. So that's it. Apologize that I ended up rushing at the end. because I didn't want to screw up the demo by moving things around, that repository is currently empty, but by the end of the day, I will upload both the slides and all the code to that. So save it and hit reload tonight, and there should be stuff there. You won't believe how much work it is to get that signed off where I work, so I hope you appreciate it. I work for 2 Sigma Investments. We're down in the Soho area. We're cool. We're hiring. So if you're interested in working on this or virtually anything else that involves computers, please come talk to me. I'd be happy to talk to you about 2 Sigma. So that's it.